Plucked from the trash, everyday objects are destroyed. Then transformed by technology, reborn into modern marvels. Bathroom faucets are forged into bronze statues. Styrofoam coffee cups pour into bike helmets. Mangoes are made into sneakers. These are the things that are made by destruction. Plumbing fixtures come in all shapes and sizes. A beautiful combination of utility and design that's built to last. But they don't last forever. Until now. Craftsmen and metalworkers are tapping their talents to turn brass faucets into timeless works of art. Every year, masters in alloy take in thousands of kitchen and bathroom fixtures and forge them into bronze used to make metal monuments. Brass faucets are recast into bronze statues. At their foundry, metalworkers melt and blend the faucets to turn them into bronze. Drumloads of fixtures arrive at the smelter. The chrome-plated brass taps are mostly made of a copper-silicon alloy, the perfect base metal for a conversion to bronze. The first step is to turn the taps into molten metal. A forklift offloads the faucets, which weigh about 1 kilogram each, into a shovel. A crane hoists the shovel across the foundry and eases it into the mouth of a furnace. A metalworker loads the pieces into the oven. After 2 hours at 1,400 degrees Celsius, the faucets liquefy into bubbling brass. The worker scoops up a sample of the molten alloy to analyze its composition and determine what needs to be added to turn brass into bronze. Both brass and bronze contain high concentrations of copper and zinc. The worker needs to add manganese to convert this alloy into bronze, which is darker in color, harder wearing, and more rust resistant. Now that the chemistry is right, the bronze can be poured into molds. The liquid metal flows from a spout and fills a ladle. After about 25 minutes, the container tips the contents into ingot molds. The ingots travel along a slow-moving conveyor, cooling as they go. At the end of the line, the charred bronze ingots fall into a bin where they finish cooling off. A forklift transports the ingots to a cleaning station. Next, the ingots load into a tumbler. Inside the rocking metal cradle, the ingots knock against each other, which removes any spurs and sharp edges. The bronze ingots emerge shiny and clean. A worker stacks and straps the ingots onto a pallet. This former brass faucet has been sculpted into bronze ingots, ready to pose for a statue. Art Casting of Illinois specializes in fabricating fine art sculptures. Once the ingots arrive at the workshop, they create the bronze replicas using a process that dates back 5,000 years called lost wax casting. Today, they are reproducing a statue by Renaissance master Michelangelo. The statue will be cast in 2 halves. Each half is coated in silicone, which dries into a rubbery shell. The original clay models are removed, leaving a detailed negative form inside. The shell is encased in plaster to keep the shape rigid. To make the wax replica, the artisan heats wax with a blowtorch and pours it into the plaster casing, gradually filling the silicone cavity. Once the wax is cooled, the worker pulls the top half of the statue from its plaster jacket and splays open the silicone, freeing a perfect wax copy of the original clay sculpture. This silicone shell can be reused to make additional wax copies of the artwork. Next, in a process called spruing, the worker attaches a wax funnel and tubing to the head, shoulders, and torso of the copy. These will be the arteries through which the molten bronze will flow. In creation step 2, the craftsman covers the wax figure in a ceramic shell. He dips the upper body into a ceramic slurry, which captures every contour of the sculpture. Then, he sprinkles it with a fine silica sand until the coating hardens into a 10mm thick casing. An artisan places the ceramic molds of both halves of the statue into a kiln to bake for 25 minutes. Inside the oven, the wax statue burns off and drains out, which is why the process is called lost wax casting. The extreme heat blanches and hardens the ceramic shell. The cavity inside is a perfect imprint of the original sculpture and ready to be bronzed. Artisans cast a classic work of art in beautiful bronze and make it gallery ready. Artisans create molds of a famous work by Michelangelo and prepare to cast a copy of the statue in bronze. Wearing heat-resistant gear, the artisan melts the bronze ingots in a crucible at 1,100 degrees Celsius. The foundry workers remove the crucible from the oven with a set of lifting tongs and pour the molten bronze into the funnel of the ceramic molds. Once the molds are filled, they bury them in sand to slowly cool. Once the bronze has hardened, workers crack open the ceramic shell and release the bronze head and torso of the statue. The process is repeated for the bottom half of the sculpture. The spruing that channeled the molten bronze into the cast is cut off. A worker then welds both halves of the statue together. He grinds away rough edges, filing and sandblasting the surface until it's identical to the original. The statue is complete. A flawless bronze miniature of an iconic masterpiece. Modern technology and ancient techniques have come together to reimagine a tapped-out bathroom fixture into a work of art. Expanded polystyrene cups, street name Styrofoam cups, are lightweight, strong, and cheap. That's made them ideal for keeping coffee addicts on the go. But of the 15 million tons of EPS produced every year, only 15% of it is repurposed. That's because EPS is extremely difficult to recycle. Now, Polysource Manufacturing in Piqua, USA, take in hundreds of tons of discarded styrofoam and break it back down, creating street-smart solutions that can save you from a major headache. Styrofoam cups are reformed into bicycle helmets. The workers at Polysource grind, compress, and recycle styrofoam into a reusable raw material. Styrofoam cups are made from tiny 3mm beads of polystyrene. The beads are steamed at 200 degrees Celsius, which causes pentene gas to escape. Air fills the gap, expanding the polystyrene pellets to 40 times their size. The beads, which are 95% air, are then pressed into molds the shape of cups. Turning cups into helmets starts by turning styrofoam back into polystyrene beads. A worker empties the cups into a hopper. A twin-shaft shredder chops the cups into chunks, which feed into a compactor. A ramming arm squeezes the pieces of styrofoam together, compressing them into a dense EPS beam. A worker breaks off stackable blocks and loads them onto a pallet for easy transport. Next, the styrofoam is ready to be ground even smaller. The worker places the blocks onto a step conveyor. It feeds a 100 horsepower grinder. Blades shred the pieces, reducing them to flakes. A blower propels the featherlight flakes through overhead pipes into an extruder. Inside, an auger winds the styrofoam through the barrel, which melts the flakes at 430 degrees Celsius. The auger pushes the molten material through a screen, turning it into strands. A high-speed rotating blade cuts the polystyrene into small, uniformly sized pellets. The pellets float in a water trough to be cooled. They land in a warm air dryer and drop into a 500-kilogram bin. Styrofoam cups have been crushed, shredded, and processed into polystyrene pellets, tiny building blocks that will be reconstructed into protective headgear. The pellets are shaped, popped, and pressed into bicycle helmets. Workers at Polysource grind styrofoam cups into flakes and run them through an extruder to reconstitute them into polystyrene pellets. A forklift hauls the bins of pellets to a second extruder. Inside, the pellets are melted and blended with a black colorant. A proprietary expanding agent is added that will puff the pellets back into styrofoam. The heated screw pushes the molten material through a die plate. The compound comes out as long black strands. They snake through a cooling water bath. A blade slices the strands into 1 by 4 millimeter beads, which tumble into 1,000 kilogram hoppers. A worker wheels the hopper to the steamer. Steamed heat will expand the polystyrene back into styrofoam. At the steamer, a vacuum sucks the pellets into a large pressurized drum. Jets of steam engulf the polystyrene beads. The steamer acts like an industrial-sized popcorn popper. 200 degrees Celsius heat causes the expanding agent in the pellets to escape and replaces it with air, inflating the pellets like popcorn, which grow to almost 40 times their original size. The inflated styrofoam floats into a hopper, ready to be reformed into a bike helmet. A worker hooks the hopper to an injection mold and pipes the hot pellets into the machine. A worker loads the helmet's plastic shell into one side of the mold. The operator starts the machine. Once the door shuts tight, the expanded polystyrene pellets are injected into the mold, filling it with shock-absorbing foam. The foam forms around the exterior plastic shell, bonding them together. The worker then removes the foam-injected helmet. A weight test confirms that the styrofoam inserts are the right density to protect the cyclist in case of a fall. The worker adds strips of padding and clips on a chin strap. This helmet is road ready. Old styrofoam cups that kept your coffee hot have been reformed and repurposed into a cool new helmet that will keep you safe on the street. That's using your head. Mangoes are the most popular fruit in the world. About 45 million tons of the tropical fruit are produced every year. They're delicious to eat, but tough to time. Wait till they're ripe, and they risk getting soft and getting tossed. So tons of the tangy fruit never make it to the table. Now, an inventive startup in the Netherlands is taking steps to turn mangoes gone bad into something good. Every year, Fruit Leather Rotterdam takes tons of rotten mangoes and other fruit and turns it into a treat for your feet. Mangoes are cobbled into sneakers. In Fruit Leather Rotterdam's plant, fruit tanners mash, boil, and dry mango fiber into sheets of durable material. To process fiber, the mangoes first have to be mashed. Shipments of food waste land at the loading dock. A worker carries buckets of the rotting mangoes into the workshop and pulls out the pits. Then, he empties the pulp and skins into an oversized food processor to chew the mango chunks down into a smooth puree. He passes it through the mixer several times to achieve the right consistency. Now the mango mush needs to be cooked down. The worker pours the puree into a cooker, blends in a binding agent, and turns up the heat. Slow cooking the mango prevents fermentation and kills off any bacteria in the fruit. The puree is reduced to a sticky paste. Much of the moisture has been cooked out, but it still needs to be dried further. The tanner drops a glop of mango paste onto a glass tray that is 40 centimeters wide by 60 centimeters long. He spackles it into an even layer. He loads the sheets onto a rack. Then slides the fruit platters into a dehydrator. The mango sheets cook low and slow. Warm air circulates inside the dehydrator, pulling the moisture from the fruit while preserving the oils so the fibers maintain their elasticity. The worker removes the sheets. The sheets retain only 20% moisture. The dried mango is now strong and stretchy. Mangoes contain fibers called hemicellulose, cellulose, and lignin. When dehydrated, the fibers form a tight matrix that's strong enough to be made into footwear. Mangoes have been pitted, pureed, and dried into fruit material, ready for the next step in becoming sneakers. The Stahl Company, in the heart of Walwick, Netherlands, treats fruit material to try to make it as waterproof and weatherproof as conventional leather. Workers unwrap the mango material and place it on a wire conveyor belt. The belt slides the sheets into a glass-walled coating cabin. Inside the spray booth, rotating nozzles shower the fruit material with a mist of preservatives and waterproofing agents. The spray permeates the sheets. The staggered wired surface allows for maximum saturation. Once they're soaked on one side, workers hang the sheets on drying rungs. Then, they flip them over and feed them back into the coating cabin for another round. The mango sheets are dry and watertight and ready for the leather look. The worker chooses a patterned press plate. He positions the stamp into a press and inserts the mango sheet. The plate is heated, and the press embosses the sheet with an authentic leather grain. At quality control, an inspector tests the embossed fruit material, stretching it to the limit and tearing it apart to confirm it's up to spec. It's now ready to be cobbled into a shoe. Shoemakers cut, stitch, and craft the fruit material into plant-based sneakers. In the Netherlands, fruit tanners mash, press, and dry rotting mangoes, processing them into resilient sheets of fruit material. The sheets arrive at the footwearists, where cobblers will cut, sew, and shape the mango material into stylish sneakers. Step 2 of creation is cutting. A shoemaker uses a pattern to cut the embossed material into the top of the shoe called the upper. To cobble a shoe together, the upper part of the sneaker is cut and sewn into shape. Eyelets are punched along the edges where the laces are strung. An insole is nailed to the bottom, then glued onto the sole. At the sewing machine, a seamstress stitches the shoe's upper. She tests the shape and size of the upper by placing it on a foot-shaped block called a last. Using a wooden last to stabilize the upper, the cobbler taps nails through the edges of the mango material to secure it to the insole. Then he applies shoe cement along the inside rim of a cushiony rubber sole. He fits the insole into it to glue the two halves together. The shoemaker punches eyelets for the laces into a separate strip of mango material. Back at the sewing machine, the eyelets and upper are stitched together to finish the sneaker. These shoes are ready to hit the ground running. Rotten mangoes have been pureed, processed, and tanned into fruit material, turning food waste into footwear. Now that's what I call a sweet pair of kicks.